Hi, this is Mr. Max. I am doing part 3 of 2021 AS level paper 1. I'm starting off with question 8. It says each year a company donates money towards the prize giving ceremony held at a school. The company increases the amount of money donated each year by 10% of the amount donated in the previous year. So that 10% there indicates 100% plus 10%, which is like 110%, which is equal to 1.1. And this 1.1, this is the common ratio. So that 10% increase then indicates clearly that this is a common ratio. Our first term is the donation that was done right in the first time, which is in 2010, which is $1,000. Okay, we have the common ratio, we have the first term, then part A then proceeds to say, find the total amount. Again, the key word here means we need to add things, so we have to find the sum. Okay, right, it's also important that you read a bit further of the money donated to school during the years 2010 to 2018 inclusive. So what that actually means is that if you were to say 2018 minus 2010, because it's inclusive as you are counting, you have to add 1. Okay, so this is giving us our n, and which you see then n is equal to 9. So we need to find the sum of s sub n. All right, so we know the formula is the first term in this case, which is 1,000, then it's 1 minus 1.1 all raised to the power of 9 all over 1.1 minus 1. Okay, so this is going to definitely give us a value. So let's grab our calculator. So with 1,000, let's just make sure that our calculator is S one would have added. Okay, so that's 1,000. In bracket, we have got 1 minus 1.1, or the other way around, doesn't really matter. Okay, and you close that, and then under would be 1 minus 1.1. Okay, so that answer there, 13,579. So it's 13,579 point. So we can go ahead 47691. 47691. Okay, so this is money, but in any case, they are saying we must give this answer to the nearest 10 Namibian dollars. So to the nearest 10 Namibian dollars, obviously this is what is going to be affected. So our answer is going to be definitely it's going to be 13,580. Okay, of course, that is Namibian dollars. Right. Uh, Part B of the second question, it says another company also decides to donate 1,000 Namibian dollars in the same year. So the first term is 1,000 as well. This company, however, increased the donation each year by a constant amount. That constant amount then indicate that there must be some sort of common difference. Okay, and if that is the case, then this is an arithmetic progression, right, where we need to determine what our D is, and our D here happens to be called A. Then they say find the value of A from for which the total donation for the years 2010 to 2018 inclusive, so that means n is still equal to 9, will be the same as our previous answer. So our S sub n will be the same as 13,579.47691. Okay, so this is from our previous answer over there. Okay, so what do we then know? We know that the S sub n formula of an arithmetic progression is n over 2, in this case 9 over 2, and we're going to have 2 times 1,000, okay, And then we're going to say plus, our common difference is A, so 9 minus 1, and all of this should equal to 13,579.47691. Anyway, please do not write in that margin over there. Okay, so once you multiply this out, you're going to see that this is simply 9,000 plus. So this is the same as going to be 8a, all right? So this 8a, this 8 that you're going to get multiplied by 9 over 2, that is going to give you 36a, okay? So again, you have 9 upon 2, multiply that by 8. That's where the 36 come from, okay? And this is equal to 13,579 and some change over there. So of course we need to find the value of a, okay? So that entail means 36a is equal to 13,579 and some cents over here should subtract 9,000 from it. So ultimately a would be whatever that answer is over there, 13,579.47691 minus 9,000. You should divide that by 36. Okay, you can grab your calculator and then you can calculate, and then you obviously should get that A is equal to 127.207 and so on and so on. So I would then also say therefore a equals to 127.21 if I have to leave my answer like so. Okay, right. So let's get to the next part of the question. So obviously, I left here some blank pages because perhaps there was some information, but it's very important that you don't try to squeeze everything on the same page. Okay, so I guess I'll go then directly to question 9. So let's just get to question 9. So question 9 says the diagram shows part of the curve. The curve is y equals to 9 minus x squared, only part of it. And it is intersecting the y-axis at 0, 9, as you can see. And it's intersecting the x-axis at 3, 0, as you can see. Right. So they want us to find the area of the shaded region. So in order for you to find the area of the shaded region, you need to know that that implies that you have to do integration. All right. So the integral, or let me first write down. So here I'll have y equals to 9 minus x squared. So I'm going to use both methods. All right. So we are going to say the area is going to be the integral of 9 minus x squared with respect to x between the limits of 0 and 3. Okay. All right. So that is going to then give us that. I'm just going to say equals to. I'm going to bring in my square bracket over here. So that is going to be, if you integrate, that is going to be 9x and minus adding 1 here, that is x cubed upon the same denominator. And the limits are from 0 all the way up to 3. Okay, so basically this should give you straight ahead where you now say, okay, I have my 9x. So 9 is going to be x will replace by 3 minus 3 cubed upon 3. Subtract. Now here's the thing, when I put 0 in here, I can see that everything will equal to 0, but I'm just going to put it there just because. So I'm going to have, if you work this out over here, so we're going to have 9 times 3, which is 27, minus 27 over 3, that is 3 cubed over there. Of course, that gives you nothing but 18. So this answer here is 18 minus naught, so it's just 18 units square, and that would be the area under the graph. Now, what if someone said, wait a minute, I want to use the I want to do the area by looking at its y-axis with respect to the y-axis, right? But before I do that, I want to introduce you to this particular rule over here. So if you have some um, function that is raised to this power, of course you have to know how to use the chain rule, but in any case you're going to take 1 all over this a, and then you're going to add n plus 1, then you multiply it by ax plus b, of course, n plus 1. So of course it's plus c, but since I'm going to integrate with to find the area, there is no need for you to put a plus c into that stuff. So I'm just going to go ahead and also remove that. So the reason I brought that all up is that in order for me to integrate with respect to the y-axis, then um, I have to make the x in this equation the subject of the formula. So that's y equals to 9 minus x squared. I need to make x the subject of the formula. All right, so step by step, so this becomes then y minus 9 is equal to x squared, the x squared being negative. I'm just going to go ahead and put it in parentheses or in brackets. So I'm going to get rid of this negative 1 over here by dividing throughout by negative 1. So that means negative outside the bracket, and this is going to be positive, right? So before I do that, I'm just going to distribute that negative over. So that's going to give me positive 9. That's negative times negative 9. And minus y is equal to x squared. So in any case, this gives us that x is equal to the square root of 9 minus y. And since the the value of x here is greater than 0, because you can see it's in the positive direction, I'm going to have a positive 1 over here. Okay, but no need to then write it, okay, since x is greater than or equal to 0, as you can see where the graph is. Right, so now we made the x the subject of the formula. So if we now had to integrate, we are going to say the area would be the integral. Of course, this is going to give me 9 minus y all raised to the power of a half. Of course, this is being squared. I just want to indicate, but I'm just going to write it anyway. And this is now from 0 up to 9. So if you go back to your graph, you will see that it's from 0 up to 9. Those are the limits of integration. Of course, you are going to integrate this with respect to y. Okay, with respect to y, so those variables should be the same. Right, now here's the thing, and that is why I brought that rule in, so you can scroll up or you can quickly refer back to that rule that I've indicated. So our a here, is this negative 1 that is here. So the way that we are going to do this one, then we're going to say, okay, let me bring in my square brackets as I start to integrate. So I'm going to have 1 all over, well, this a is negative 1, and then obviously you are going to say n plus 1. So when you are adding 1 to the index, you are going to get 3 over 2 if you do so. And I'm going to multiply that by 9 minus y, obviously raised to the power of 3 over 2. And obviously this is from 0 to 9. So let's just clean it up a little bit. And if you do clean this up, of course, this whole business over here is nothing but negative 2 over 3. Okay, that is what that is going to give you. And obviously, if you then take 9 minus y raised to that power from 0 to 9. Okay, so now we're just going to insert our values. So you can already see that this is taking quite longer than usual, and I would suggest that maybe you go for the one that is a bit easier. So let me just insert one more page over there. um, okay, so these type of things, they do happen. All right, so I'm just gonna save and close this off. So I'm gonna go back in there um, uh, just some technical difficulties. But in any case, that is going to take me directly back to where I was. Um, okay, let's just restore. So I'm working here with an annotator. So I was all the way over here and I wanted to include a blank page. All right, so I'm just going to insert a page so that I can have more space to work. All right, so in any case, this then gives me um, -2/3, and obviously this is going to be 9 minus 9, the upper limit there, okay, all raised to that power over there. Okay, so perhaps you can also put this in brackets, so whatever that value there would be, minus, and then I have -2/3, and obviously 9 minus 0 all raised to that power over there. Okay, and this should give me the answer. All right, any case, if you do the first one, you're going to get a 0. Okay, this is simply going to give you 0 because 9 minus 9 there is 0. Square root of 0 is 0. Anything, is just going to give you 0. So I have a negative over here. And inside here, if you then have to calculate it, you're going to get -18. So of course you can use your calculator if you want to find what this particular value would be. So -2/3, and then obviously this is going to be in the brackets. It's going to be 9 simply, and it must be raised to the power of 1.5, or 3/2. Well, you get -18 as indicated. All right, so then a negative and a negative inside yields a positive result, giving us that the area under the curve is nothing but 18 square units. Since I don't know what the units are, I'm just going to write like so. Okay, so for 3 months, I think you can agree with me that this is rather a very long process. But of course, I will need this in order to do the second part of the question, which involves me to do some volume of revolution. Okay, because I already made x the subject of the formula. Okay, so let's then get to that part of the question. So I'll just simply refer back to that. So for 4 marks, it says, showing all necessary working, find the volume generated. So that solid that will be generated there in terms of pi. Okay, so it's like a little disk if you really had to look at it. We have to then find that volume when that shaded region is rotated through 360 degrees about the y-axis, and because it is rotated about the y-axis, that volume would then be whatever the limits are, the integral of pi and then x squared with respect to y. So let's just go ahead and maybe you just keep this as a formula that we want to use. Now from our work before, we know that we had our formula was y equals to 9 minus x. So this again was raised to the power of a half. And when we made x the subject of the formula, remember we had, and if I just have to go back so that we can get it, um, of course, we had, so let me see quickly, all the way back we had 9 minus y. Can you see that? 9 minus y over here. This is what I'm looking for. So I'm just going to say, okay, so this is the same as x equals to 9 minus y, all raised to the power of a half. So this is definitely what I'm going to carry over, okay, into that integral. So I'm going to come over here because it has to be with respect to y. Okay, so um, it was 9 minus y all raised to the power of a half. Okay, so the volume therefore would be, I'm just going to go ahead and bring out that pi, and it's going to be the integral, of course, from 0 to 9 because it's about the y-axis. And okay, and so I have got 9 minus y raised to the power of a half. Of course, that is squared with respect to y. Of course, there was no need for me to write a half squared because eventually they cancel each other. if you could see that, but I just thought let me do that anyway so that you can have an idea. Okay, so from here again we can go and just say, okay, this is going to be the integral from 0 to 9 of 9 minus y with respect to y. Okay, so let's then go ahead and integrate. Okay, so if I do that, I can again take out the value of pi. Don't forget the value of pi. And this is going to be 9y. And this is going to be add 1 there. So it's going to be y squared upon 2. Of course, this is from 0 to 9. So let's just go ahead and substitute in our values. And this is going to give me the pi value over here. Of course, this is going to give me 9 times 9 minus 9 square over 2. Well, of course, I'm just going to say minus 0 because if I was to put 0 everywhere there is y, it's just going to be nothing then. So, of course, using your calculator, 9 times 9 is 81 minus 9 square. So let's just go back, 9 square upon 2. So that gives me 81 over 2 or 40.5. So that is 40.5. Of course, don't forget the value of pi. And again, this is units cubed. And the reason why I leave my answer in pi, in terms of pi, because it continues to tell me here, leave your answer in terms of pi. Okay, all right, so let's go ahead and let's go to the next question. Question 10, the line y equals to mx plus c, which is a straight line, where m is obviously a constant, and as you know that m there is representing the gradient. It says this line does not intersect the curve. So well, I believe that maybe this information I have over here is not for is not for this particular question. So let me just go ahead and cut this and perhaps go to the next question. um, uh, I want to see just so that I can follow where we are. Okay, all right. So I think that has to do equation of a normal to the curve. And then we have got the equation of a curve, question 12. So let's just go ahead and see what question 12 is about. I believe it's about a function, all right, and its inverse. Okay, so find the equation of a normal. All right, no, so this information has got always have two real roots. I think I will use it over here. Okay, I will use that information over here. Explain why the equation will always have two real roots, and in this particular case, even this stuff over here can just be removed. Okay, because this has got no bearing on this question whatsoever. This question says you have a line and this line does not intersect, therefore the discriminant should be less than 0. Right. So what you do is you then go ahead and you equate them. You say x squared minus 2x plus 20. You equate them is equal to mx plus 4, and everything should move to the left. So you're going to have x squared minus 2x. Just write that 2x nicely. Minus 2x. Of course, if you bring that mx, it becomes a minus mx. Okay, and then you have got your 20 over here, and of course if you were to bring that 4, it becomes a minus 4. All right, so this equals to 0. So this gives me x squared minus, of course negative and negative give you a positive, but I'm just going to leave it as minus 2x minus mx for now, plus 16 is equal to 0. Okay, right, so let's just take our critical values over here. So maybe just to write what this is over here. So this is over here is going to be minus 2 plus m, of course, with that. All right, so the value of b square, because remember, my discriminant is b square minus 4ac. This is equal to the discriminant. So my b value there is obviously going to be minus 2 minus m okay, if I distribute that, minus 4 times 1, obviously times 16. Right, so I know that this has to be less than 0, but I'm just going to go ahead, maybe I should do that, less than 0. All right, so let's just quickly multiply these out. So this is going to give me m squared. In fact, you can write this as 4 plus 4m. In fact, let's just write it nicely. So anything here becomes positive, and if you were to do this, this is the same as saying 2 plus m, though, squaring. You just want to make it a little bit more easier for you to find that. Doesn't matter, you're going to get the same thing. So this is the same then as m plus 2, which gives me m squared plus 4m plus 4 minus, so when you multiply these two, you get a 64 over here. Should be less than 0. So obviously m squared plus 4m, and then you have minus 60 is less than 0. All right, so I also now know from my work over here that we are dealing with an inequality and how you look at quadratic inequalities. Well, if you were to sketch this, then this is going to have a minimum value, and our critical values, we're going to calculate our critical values, but our solution will be below the x-axis. All right, so what we are now looking at is we are going to see what is this particular range over here. So we're going to find our critical values by saying m squared plus 4m minus 60, let that equal to 0. So I'm letting that equal to an equation so that I can find the critical values. All right, so this is then m plus 10 if you were to factorize, and m minus 6, of course that equals to 0. So m equals to negative 10, or m is equal to 6. So that is 6 over there, and that is negative 10 over there. So my solution, therefore, because it's below the x-axis, will be m is less than, okay, less than 6, and m is greater than negative 10. And this is the solution that we are looking for. Okay, so the second part, of course, they're saying explain why this equation 3x squared minus kx minus k squared equals to 0, where k is a non-zero constant, always has two real roots. In order that for us to prove that the equation always have two real roots. Remember, you're not solving this equation. You have to show that the discriminant will never be negative. So that means that the discriminant, whatever it will be greater than or equal to 0. Okay, that is the general setup over there. Of course, I will take away the or equal to 0. Let's just bring that back over there. So let's just say it will be greater than 0 because they are saying it has got two real roots. Okay, so again, going ahead, you're going to say the discriminant. So you're going to say the value of b, which is negative k square minus 4 times 3 times. Now here you need to be a little bit careful, and you must see how I am writing. So inside I'm writing negative k squared as opposed to writing that outside. Okay, this is very important. So this gives you k squared. Now you're going to have a negative times a negative over there, so it's going to be positive 12. Okay, so total 12k squared, which then give us 13k squared. So please do not get confused with negative k all squared. This answer here is positive, while negative k squared inside this answer here is negative. So very important that you do not make such type of mistakes. All right, since that is the case, whatever you substitute for k, whether k is a negative number, whether k is a positive number, anything that you square will be positive. So this answer will always be positive. So therefore, there will always be two real answers or real roots. Then you can say the discriminant is greater than 0, hence there are going to be two real roots. Okay, Right, the equation of the curve y equals to x squared plus 16 upon x. That is the equation of a curve. They say find the coordinates of the stationary point. So once you are told you need to find the coordinates of the stationary point, those are trigger words that tells you, of course, you need to differentiate. Okay, so I'm just going to rewrite this equation just in a better way as y equals to x squared plus 16x raised to the power of -1. Then dy dx is going to be, now remember you take 1 away, so that's 2x. So please do not get mistaken. So that's going to be a negative there, 16x -2. Right, so what do we know about the stationary point? The stationary point implies that the gradient there should be equal to 0. Therefore, I have got 2x minus 16 upon x squared should equal to 0. That's basically what that means. And let's go ahead and we solve that equation. So this is nothing but 2x maybe over 1 if you wish to say so. 16 upon x squared, right? I just move that negative term over. Just make it a bit easier. And then obviously you can go ahead and you can go ahead and you can sort of cross multiply. It should not be problematic for you to do so. So you're going to multiply this two, that gives you 2x cubed. And of course, if you multiply this two, that gives you 16. All right. So once you divide throughout by 2, you divide here by 2, here by 2. Eventually, you are left with x cubed is equal to 8. Right, so in order for you to have x alone, you need to take the cube root of 8, which is just going to be 2. Please, this is not an even power or even root, so do not go ahead and say positive or minus, so this is 2. Right, so they want us to find the coordinates, right, of the stationary point. So I have the x value. So now what you do is you take that x value and you put it back into the original equation, which was x squared plus 16 upon x. Right, so just put it back into the original equation. And once you do so, this is 4 plus 8, you're going to get 12. So therefore, our coordinates for x and y would be nothing but 2, comma 12. Okay. Right. Now let's get to part B. They say the equation of the normal of the curve. Find the equation of the normal of the curve. So what do we know? We know the gradient of the curve. So the gradient, we have the gradient formula. Our gradient formula was dy dx was equal to, I hope you still remember, our gradient equation was dy dx is equal to 2x minus 16 over x squared. That was our dy dx, okay? That was our dy dx over there. Right, so we now are going to substitute x equals to 4 in order for us to find what is the gradient of the curve at that point. So dy dx when x is equal to 4 is going to be 2 times 4 minus 16 upon 4 squared. Of course, that is 8 minus 1. So the gradient is 7. Right, so the gradient of the normal, the gradient of the normal, I'm just going to say gradient of normal, is going to be perpendicular to this, which means the gradient there will be -1 over 7, because the two, if you multiply the gradient of the tangent multiply by the gradient of the normal or the gradient of the curve at that point times that, should give you a product of -1. Of course, now maybe I should go ahead and insert one more page. Okay, so just so that I can have some space to work. Okay, so that's not where I wanted the page. So let's just quickly go down, down, down. Just bear with me. Okay. Right, let's just insert the page now. Inserting the page. All right. So the gradient of the normal. So what we now have, remember the formula, and it's very important that you remember the formula, the equation of the normal. So first let's write down the points. We are given the point 4, 20. Okay, so this point here, if you read the previous question, it says find the equation of the normal to the curve at that point. So that is a point that is being shared. So the equation of the normal, equation of the normal is y minus y sub 1 is equal to negative 1 over m, which is the gradient, and x minus x sub 1. Of course, we know our gradient. Our gradient there was is negative 1 upon 7. We have got our y value, which is 20 over here, negative 1 upon 7, and then you have x minus 4. Just make sure you substitute into the points, okay? All right, so let me distribute over there. So this is y minus 20 is equal to negative 1 over 7x here. And a negative times a negative is positive. So that's positive 4 over 7. Okay, so we're nearly done to find that equation. We're just going to bring that 20 over. So by adding 20 to both sides, so the equation would be y equals to negative 1 upon 7x plus 4 over 7 plus 20. Of course, 7 times 20 is 140. 140 plus 4 is 144.7. If you could go ahead and use your calculator, so this is y equals to negative 1 over 7x plus 144. 20 times 7 is 140 plus 4 all over 7. So this is the equation of the normal. Okay. Right. You can always pause the video, and then you can always sort of refer back to if you are getting a little bit behind. All right, question 12. So we have got the function is defined. This function is defined when x is some value that is greater than or equal to some constant. Now, you must also remember when you are dealing with functions that there are certain things that make a function to be defined and not to be defined. Like division by 0 is not possible. So if you have some function, let's say you have a function 5 upon, let's say you have something square root of x plus 2. You know that division by 0 is not possible. So what you're going to do is you're going to say x plus 2 should be greater than 0, so that whatever input for x over x here in this particular case must be negative 2. And that answer, anything greater than negative 2, like negative 1, 0, and so on, would then define this. There would be an answer for something like that. Right. We don't have a denominator here per se. But what do we know? We know that when we are dealing with square root, the square root of 0 exists. Okay. But the square root of a negative number, this one does not exist. It's undefined. So the stuff under the root should be 2x. The stuff under the root, which is the 2x here, plus 2 should be greater than 0. Okay? Or it can even equal to 0. That is something that is worth understanding. Right, so let's go ahead and solve this particular inequality. Right, so that is going to be 2x is greater than or equal to negative 2. Divide throughout by 2, so 2x is greater or equal to negative 1. Now compare that with x is greater than or equal to k. Therefore, k is nothing but negative 1. Okay? Right, so they say for the value of k found in part 1 or part A, find an expression for the inverse, and then you must state the domain. Let me just come back to that particular function, the one on top. This x is greater than or so. So let me just explain a concept here. This x is greater or equal to negative 1. This now is the domain. Once you take this x negative, which is greater or equal to negative 1, and you input it under here, you're going to get the range, because this is the same as y equals to that business over there. That's 2x plus 2. So if you were to input that value, and you have 2 with negative 1, for example, plus 2, you'd realize that y is supposed to be greater than, okay, I'm just going to have it like that, greater than or equal to 0. So whatever my range would be, That is the concept over there, because that is going to be -2 plus 2, which is the square root of 0. So my range must be y is greater than or equal to 0. Why is that important? Here they are asking us to find the domain of the inverse. So the domain of the inverse would be equal to the range. The domain of the inverse will be equal to the range of the function. So the domain would be x is greater than or equal to 0. That's what's going to happen over there. But anyway, we'll explain it a little bit more in detail. So let's take the function as we know. The function is y is equal to root 2x plus 2, and we need to find the inverse. So again, go ahead and swap the, of course, remember you want to make a, swap the letters. You say x equals 2, and then you're going to have 2y plus 2. So the idea is to make y the subject of the formula. So first get rid of that square root by squaring both sides. So this is going to be x squared is equal to 2y plus 2. Right, so that's x squared minus 2 divided by 2. That's going to give you y. However, we are looking for the inverse. Please, this is the inverse. Please, this have nothing to do with differentiation. Okay, do not get confused like that. All right, so that's the inverse of the function. Right, so the domain, we already established that the domain is going to be equal to the range of the function, and the range of the function, we just take our value of negative of x greater than or equal to -1. You input it over there, and then we have our domain, which is going to be y is greater than or equal to 0. That's the domain of the function. This domain of the function will be the same as the domain of the inverse, and I hope you still remember that little sort of combination you have. So if you have a function, if you have a function f of x, and then you have its inverse of the function, so the domain over here, let's say the domain over there, here you have the range, here you have the range. So the domain of the function is going to be the inverse, the range of the inverse. And the domain of the inverse is the same as the range of the function. So when I said the range of that function is y is greater than or equal to 0, then that is the domain of the inverse, which we have in this case, the domain here, if I have to write it again, was x is greater than or equal to 0. Right, the last part is we now have to sketch these things. Right, it's very important that once you sketch that you do not forget that you have to have the very first thing, you must have an identity line. The identity line is the line y equals to x, so we can actually bring that line in. It's going to be a dotted line, so y equals to x, that is the identity line, because the function and its inverse will be symmetrical about this line over here. So let me just write down our function. So our function, let me see if I have space to work underneath. Okay, so I'm just going to work everything over here. Our function f of x was the root of 2x plus 2. Our inverse function, the inverse function, was x squared minus 2 upon 2, right? And if you were to, let's say we work with the function, okay? So let's take our function there, and let's say from f of x, we say let x be equal to 0. So what will y be? So of course, if you let x equal to 0 over here, y is going to be the square root of 2, okay, which is about 1.4 something something. Maybe we can bring in another point, okay? Maybe we can bring in the point -1. If x is equal to -1, so if I put -1 in here, what is the output? Of course, the output will be 0. Maybe we'll bring in one more point. So let's say if x is equal to 1. So 2 times 1 is 2 plus 2 is 4. The square root of 4 is 2. So these are points that one can plot. So in order for me to find the, when x equals to to -1. So -1 will be over here. So then we have got that as 0. Let's suppose this here is going to be the square root of 2. And another one is when x equals to 1 over here, I have another output of 2 somewhere out there, which is maybe somewhere there. So anyway, what we're going to deal with is we're going to deal with a function that kind of turns like that. Now here's the thing now about that. So it's going to have if x, so the inverse of the function, so the inverse of the function, if I have to complete the inverse of the function, you're just going to swap the coordinates around from what you have over here. All right, so that is going to be a √2, and that is 0. That is going to be 0, and that is going to be -1. And of course, that is going to be 2, and that's going to be 1. So that's what you're swapping. So basically, now this one is going to cut the x-axis. So let me just come back here. It's going to cut the x-axis at √2. Okay. And it's going, this one cuts the x-axis -1. So it's going to cut the y-axis here, of course, at -1. So you can see it has to go something like that. And wherever that is there, so if x was 1, remember I had a 1 somewhere here, and then obviously you also had some output there. But let me just go ahead and plug that in. So let's just use maybe a different color. So that function has to be symmetrical. So basically it will come something like so. All right, so this is how you're going to have it. So I'm going to label, this one is going to be the inverse function, and the blue one is obviously going to be the function itself. Right, I have indicated my intercepts, I have indicated my graph, and I've labeled them, and that is worth 4 marks doing so. Of course, you would see a nice graph there that I have done down here. Okay, so right, this particular point over here, this point here is the square root of 2. All right, this point here is the square root of 2, which is about 1.4, and so on. So that's how it should look like. All right, so again, I've been using some values. You see what the output is. If you look at the value of the red one, which is the function, if f of x has an output for x, if x output is f of x is 2, then the value of y is 1. Okay, let's see. Yeah, and so on. So again, the inverse will be totally opposite. So let's just look at the inverse, which is the blue one there. So the inverse, I'm just going to make it like this. So the inverse would be, if we now take our x and our y, if you go to the inverse, so this has to swap around. So the inverse is this one. So if we look at x, when x is 1, can you see this point here? Then look at what is y. Y is 2. So when x is 1, y is 2. Can you see that you're swapping the points? So once you know the particular points, let's say you know some points of the other one, okay, that's 7 over there, you can find, then those points will just be swapped around in order for you to find the other points of the other function. Okay, so that one all the way up to 7, so 7 is somewhere up there. Okay, so I hope that is clear. All right, the last part of this question, it says now find the value of, now you must be very careful. This is differentiation. This is not anything to do with the inverse. All right, so what do we know? We know that our function originally, our f of x is nothing but the root of 2x plus 2, which I can actually write as 2x plus 2 all over, or all raised to the power of 1 over 2. So if I was to do dy dx, or I find the first derivative, of course, I will just go ahead, baby, and I'll say let this then equal to y. So this is my y, so dy dx. Now, remember, you are taking that 1 over 2 in front, and obviously you are going to say, um, uh, now it's very critical that you do realize you use the chain rule when you differentiate. So that's going to be 2x plus 2. All right. So obviously you're going to then take away 1 from here, which is going to be negative a half. So multiplying the negative half. And then you do the derivative of the function inside. It's just going to be 2. Okay. You do it separately. Okay. Let's just clean this up. A half times 2 times 2x plus 2 all raised to the power of negative a half. Of course, those two cancel. Then this is going to give me that the derivative is nothing but 1 over 2x plus 2. Of course, all raised to the power of a half, or like that. Right. So what does it imply? Now, it implies that if dy dx, and when x is equal to 7, okay, because they want us to input for f of 7, so that is the derivative of 7, that is nothing but 1 upon 2. Of course, remember this is root, so I just want to change the color. So this is obviously where you're going to have the 7. Of course, this is going to be 2 times 7, which is 14, plus 2 is 16. So 1 over the square root of 16, which is nothing but 1 over 4. Okay, so I hope that you have learned something as far as these paper ones are concerned.